What is the formula for bisection method? That is x1 equal to half a plus b. X to the power x equal to 100, lying between 3 and 4, carry out 5 iteration. Fourth iteration, I'm going to consider a and b value and I'm going to get the value 3.56. Hello to all, a warm welcome to my new session on roots of equation. I'm Revati from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, in my last session, I started with introduction about roots of an equation. Then I have discussed the type of equation. Along with that, I have discussed iterative method. Under iterative method, we are going to have three type of iterative method, that is bisection method, regular falsy method or false position method, and we are going to have Newton-Raphson method. And I have solved some of the problems under iterative method. But in my today's session, I'm going to start with the first type of iteration method, that is bisection method. Along with that, I'm going to discuss some of the worked example. Now, what is bisection method? Why we require bisection method? So dear student, if I consider any given equation that is represented in the form of f of x equal to 0 and let a real root of this equation lies in the interval a comma b. That means if I take any equation that is represented in the form of f of x equal to 0 and the real root for this equation lies between a and b. Assuming that f of x to be continuous in a comma b, let us say f of a less than 0 and f of b greater than 0. So what's the meaning of f of a less than 0? Less than 0 is nothing but all the negative values. So all the negative values falls under f of a less than 0. And what about f of b greater than 0? That means all the positive values falls under f of b greater than 0. And when I multiply f of a with f of b, I'm going to get negative number. So f of a into f of b less than 0. So the first approximation to the root, that is x1 in this method, is the bisecting point. So what is bisecting point? That is nothing but the intersecting point. So what is my first approximation? That means I'm just going to assume that the intersecting point may be 1 divided by 2a plus b. So what is my first approximation? That is half into a plus b. Now, when f of x1 will be either positive or negative, so it is my f of x1. So if this f of x1 is either negative value or positive value, if it is positive, see, f of x1 greater than 0 is nothing but the positive value, then I'm going to conclude that root lies between a comma x1. That means a remains as it is. Where I'm going to make the modification? B. So I'm going to consider b equal to x1. Now, if it is negative, then A is nothing but the x1. That means I'm going to replace A value with the x1 value and B remains same. So, negative value, I'm going to change A, but B remains as it is. If it is positive, A remains as it is, and I'm going to make modification in my B. So, B equal to x1. Now, so dear student, if I consider second approximation, that is x2. See here, if it is positive number in the sense what? I'm going to change B value. And if it is negative number, I'm going to change A value. This method is going to continue until and unless I reach the exact root. So, if it is x2, then x3, then x4, x5, up to xn. So, two consecutive iterative values of x must be same. That means how I'm going to stop the process when two consecutive iteration values must be same. That means the present and previous iteration values must be same, then I can able to stop the iteration. So what is the formula for bisection method? That is x1 equal to half A plus B. Now, if f of x less than 0, it is negative number, then I'm going to change A and B remains as it is. So, the formula is half x1 plus B. Now, if f of x greater than 0, then it is positive number. Then A remains as it is and I'm going to change B. Therefore, the formula is modified with respect to A plus x1. So, dear student, this much points you have to remember while solving bisection method. Now, let's solve the problem. So, dear student, the first problem under bisection method is, I have the equation x cube minus 2x minus 5 equal to 0 and I want to find the real root of the equation, and when I want to stop the process when I reach fifth stage, and how I want to stop the iteration. I want to consider the 3 decimal places. I repeat the question. Use bisection method in given 5 stages. So, use bisection method in 5 stages to find a real root of the equation x cube minus 2x minus 5 equal to 0 and correct to 3 decimal places. So, dear student, let me to find the solution. So, dear student, we know the bisection formula, half A plus B. So, x equal to half A plus B. So, in this question, they did not mention the root. That means they did not specify where exactly the root lies between. So, what I want to do? I want to use the trial and error method. In the sense, I want to start from substituting x value equal to 0, 1, 2, 3 up to so on. So, what I want to do at the beginning, I want to write this equation in the form of f of x. So, I will write f of x equal to x cube minus 2x minus 5. Now, I'm going to start substituting x value, that is, put x equal to 0. And when I substitute, I'm going to get the value minus 5, which is less than 0. So, it is negative number. Now, what I'm going to do? I'm going to increment x by 1. Now, x equal 1. And I'm going to substitute this 1 in my equation. So, I'm going to get once again negative value, that is minus 6. So, what I'm going to do? I'm going to substitute x equal to 2. So, when I start substituting, it is 8 minus 4 minus 5. Once again, I'm getting minus 1. So, it is once again negative value. Now, dear student, when x equal to 3, it is 27 minus 2 into 3, it is 6 minus 5, it is 16. So, it is positive number. And according to the explanation, when we have to stop, that is when we get one negative value and one positive value. That means when I get alternative sign, in that time I want to stop the process. Now I'm going to write the or a real root of the equation, that is f of x equal to 0 lies in 2, 3. Now, I'm going to perform error and trial method for each stage. Here, what is stage? There is nothing but the iteration. And what is my formula? I have bisection formula half a plus b. Now, if f of x, that means after substituting the x value in the given equation, if I am getting positive value, so what I want to do? A remains as it is and I am going to change b value. So, it is half a plus x1. Now, if my f of x less than 0, that is nothing but negative value, then I'm going to replace, if it is negative value, then I'm going to replace a by x1, b. So, the formula is half x1 plus b. Okay, this much formula you have to remember while solving bisection method. So, here I have the formula, that is half a plus b. So, what is a? A is nothing but 2 and b is nothing but 3. So, I substituted. So, I got 2.5. Now, dear student, when I substitute this 2.5 in the given equation, so what's the given equation? That is x cube minus 2x minus 5. So, what is x here? It is 2.5 to the power 3 minus 2 into 2.5 minus 5. So, I am getting the value 5.625. So, it is a positive number because this is greater than 0. So, it is positive number. If it is positive number, what I want to do? See the condition here. If it is positive number, my A remains as it is and I am going to change B. So, my A is how much? 2. So, 2 remains as it is. Then what about B? B is nothing but my X value. So here what is X? That is X1. So X1 is how much? 2.5. So now I'm going to write the root lies between 2, 2.5. Now in my next iteration, see, I'm going to substitute the formula. So what is my A? It is 2. And what about my B? It is 2.5. And when I divide that one by 2, I'm going to get 2.25. Now, I got 2.25. This is my x2. Now, I want to find out f of x2. So, I'm going to substitute this value in my equation. And I'm going to get 1.89, which is positive number once again. If it is positive number, what is the modification I want to do? My A value. So what is A? It is 2. It remains as it is, and I'm going to change B with the X value. So what is X value here? It is X2. So A equal to 2 and B equal to 2.25. Now, in my third iteration, I'm going to divide that number by 2. So, I will get 2.125. And I'm going to substitute this X value in the given equation, that is f of x3. And I'm going to get once again positive value. So here 0.346, which is greater than 0. That is indicates that it is positive value. Now I'm going to write the conclusion that the root lies between 2, 2.125 because it is positive value. So A remains as it is. So A is 2. I'm going to modify B. So B is my previous X value, that is 2.125. Now in my fourth stage, half divided by 2 plus 2.125. So when I divide, I'm going to get 2.0625. I'm going to get 2.0625. Now, dear student, when I substitute this in my f of x, I'm going to get negative value. I'm going to get negative value. So, it is minus 0.35, which is greater than or less than. I'm going to get 3.5, which is less than 0. So, which is less than 0. So, what I want to do? It is negative number and I want to modify A value. Now, A is nothing but my previous X value, that is 2.0625. And what about B? B is my previous value, it is 2.125. So here I am going to write the conclusion that the root lies between 2.0625, 2.125. And in my next stage, that is the fifth stage. So according to the question, when I want to stop, when I reach fifth stage. So x5 equal to, I'm going to substitute this A and B value in the bisection formula and I'm going to get the answer, that is 2.09375. I'm going to stop the iteration here itself, because in the question they mentioned when I want to stop the iteration. Now, I'm going to have my second worked example, that is use the bisection method to find a real root of the equation. So what is the equation? I have x to the power x equal to 100 lying between 3 and 4. Carry out 5 iteration. So carry out 5 iteration. Now, what I want to do, I want to write the equation in the form of f of x. So, when I write f of x, then it will become x to the power x minus 100. And I'm going to start substituting the value. So, dear student, when I start with the value x equal to 0, I'm going to get negative value. When I start substituting x equal to 1, once again I'll get negative value. And when I start substituting x equal to 2, once again I'll get negative value. And when I start substituting x equal to 3, 3 to the power 3 minus 100, that is 27 minus 100, that is equal to minus 73. Now x equal to 4. So when I substitute 4 into 4 into 4 into 4 minus 100, I'm going to get 256 minus 100, I'm going to get 156. So it's a positive value. I'm going to stop the substitution because I got one negative and one positive value. So the root lies here is 3 and 4. So what is my A here? 3. And B is nothing but the 4. Now I'm going to have the bisection formula and I'm going to substitute here itself. So what is my bisection formula? Half A plus B. So half 3 plus 4 and I'm going to get 3.5. Now I'm going to substitute this one in my equation, that is f of x, and I'm going to get the negative value, that is minus 19.8. If it is negative value, then I want to modify A value. So I want to change A value. So instead of 3, what I will do, I'll make it 3.5. So now the root lies in 3.5 and 4. Now once again I'm going to substitute this A and B value in my bisection equation. That is my second iteration. So dear student, now I'm going to substitute A equal to 3.5 and B equal to 4, and where I'm going to substitute in my bisection formula and in my second iteration, and I'm going to get 3.5. And when I substitute this x2 in my f of x2, then I'm going to get positive number, that is 42.1, which is greater than 0. So it is nothing but the positive number. If it is positive number, what I want to do? I want to modify B. A remains as it is and I'm going to modify the B. So what is A here? That is 3.5. If I consider previous iteration. And what about B? B is nothing but x2 value, that is 3.75. So dear student, now I'm going to substitute this A and B value in my bisection equation. And I'm going to get 3.625. And I'm going to substitute that one in my f of x3. And when I substitute, I'm going to get positive value, that is 6.5, which is greater than 0. And what I want to do? I want to modify B value. So instead of taking B equal to 3.75. What I'm going to consider? I'm going to consider 3.625. That's nothing but x3 value. So I'm going to write the root lies between A remains as it is, that is 3.5, and what about B? I'm going to make it x3. So that is 3.625. So dear student, in my fourth iteration, I'm going to consider A and B value, and I'm going to get the value 3.56. So after that, what I'm going to do, I'm going to substitute that one in my f of x4. So I will get minus 7.6. That is less than 0. That is nothing but negative number. So dear student, in my fifth iteration, what I'm going to do, I'm going to consider A value. So what is A value? That is nothing but my previous value, that is 3.5625, because I'm going to get the negative value. So I'm going to change A with the x4 value and B remains as it is. And when I divide, I'm going to get 3.59375, and I'm going to substitute this x5 in my f of x5. So I'm going to get minus 0.803. So hence the required approximate after 5 iteration is 3.594, because it is 93. So I'm going to make it 94, because if I see 37, it is nearer to 4. So that is nearer to 40. So what I will do, I'll make it 3.594. And in the question, they mentioned when to stop when I reach fifth iteration. So when I reach fifth iteration, I'm going to stop the iteration. So this is the way I can able to solve bisection problems. Anyway, dear student, in my today's session, I started with what is bisection methods. Along with that, I have solved some example problems. Anyway, dear student, let's meet in the next session with more example problems. Until that, keep watching and keep learning. Thank you.